Yeah, so I'm going to do a talk on should you use Kotlin for your APIs, mainly focused on when you're targeting JVM applications, being Kotlin's kind of moved a bit further away from just targeting JVM stuff. It has kind of different targets now. So let's see if this works. Okay, so we've been using Kotlin at R3 for quite a while now. And during that time, it's come up a number of times of should we keep using Kotlin for our APIs, or should we move to something like, well, I wouldn't say something like Java, but go back to just using plain old Java rather than Kotlin. There's a couple of reasons for these sort of thoughts. Is things like we have a primarily Java user base. So using Kotlin instead of Java kind of introduces some complexities of compatibility with Java, how well it is to use. So this is kind of a question that I asked according to this image, is 2 years ago in the Kotlin Slack channel, kind of proposing this sort of question of, should we consider going back to Java instead of Kotlin because of our user base? I'm going to go over some of these things in this talk and discuss about where we ended up, kind of why we got there, and then also what you might want to consider if you are producing libraries or platforms using Kotlin for your APIs, and what you might want to do there. Okay, so why do we care? So I guess this is why does R3 care about this answer. So we have our product, which is Coda, and this is a platform that users write applications on top of, and it runs their code. All of these applications are written in JVM languages, so they could be Java, Kotlin, Scala, whatever, but most of them are Java applications. However, our code is all written in Kotlin, so there's already a bit of disconnect there. And then kind of a final and important point for this talk is, because we are a platform, we have a guarantee that we need to keep of whenever an application is written, there should be no reason why a upgrade to our platform should affect that application. So maybe some of the runtime behavior changes, but that application should still work. So in kind of simple terms, taken from these points, is really, we must keep Java as kind of the first class, most important citizen of our product. Because we have so many users that are writing in Java, we can't just allow them to have a bad experience when they're writing their code, just because we, as a platform, want to use Kotlin. So just because we want to write it doesn't mean our customers want to do that. And then, as I just said, like, we need to make sure that whenever we make a change, everything is backwards compatible. We're not breaking anything whenever we do upgrades. So what are the advantages of Kotlin over Java? I'm sure most of you already know this. Most of us have already probably written Java and kind of moved to Kotlin in the first place. So for example, we have better nullability, data classes, default parameters, name parameters, blah, 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 blah. So there's quite a lot of things there. But if you start trying to use Kotlin APIs from Java, a lot of these things kind of go away. You can't really use them. So nullability controls, you don't really get the benefit in Java like you do in Kotlin. You don't get the compile time safety, but there's still a bit of help there in that you can see that a type is nullable. You can see what it should be doing. So it gives you a bit there. Data classes, they're still there. They're effectively the records we have now in later versions of Java, but things like copy, you can't really use it from Java. The method is still there, but without name parameters, which is crossed off that list, and default parameters, you can't really make use of it. You have to kind of call copy and pass everything in anyway, in which case you could have just made a new object yourself. And then kind of more things like extension functions, still usable, but they're not as nice to use from Java because they just become static functions, and then you have to find where those static functions are. Whereas Kotlin, it's just, you just type a dot, IntelliJ will fill it in and it all just seems to work. And then things like reified types, that is a very Kotlin specific thing. Java you won't even see those methods in Java. And then we also have lambdas scope to this. Not a super important one, but it's just another one I put on there. So we lose some benefits, fine. So let's look at the other side as well, is if we have a Kotlin API and we're targeting mainly Java users, there is still some work we have to do. We can't just write our Kotlin code, provide these APIs and everything's okay. You still have to include things like these annotations, so JVM static, JVM filled, or JVM overloads, in certain places to keep things nice to use from Java. So if you have let's take the JVM overloads. You have a API method in Kotlin. It's got a couple of arguments into it. You've got default parameters for some of them. If you don't use JVM overloads, when you try to call this method from Kotlin, you're going to have to pass in all those arguments. There is no benefit of it having those default values in the first place. So something like JVM overloads, what that does is it creates the overloads for those methods for you, so you don't have to go and create them yourself. Whether you create them yourself, that's a different argument. I would argue for doing that. Another one which is a bit weird, you probably don't realize it until you kind of hit it, is if you have a lambda that returns something like unit, in Java, it can't kind of infer the return type the same way that Kotlin can. So it's just kind of a bit of gripe. You still have to return something from these sort of functions. So you would still have to return unit, or you'd have to return null, even though you would kind of hope you would be able to just return nothing and treat it like a void method. It doesn't really work like that. So these are some things you can kind of bypass if you code for it correctly. But it's hard to guarantee you do that right. Like, the reason why I'm able to say these things is because we've had these issues, we've made these mistakes, so we know that they can happen. And it's quite likely that other people will run into the same problems as well. So that's kind of why I'm talking about this right now. So this is kind of the main part, the main issue we've had with using Kotlin for our APIs. So upgrades. Now, remember the important part that I stated before is that we produce a platform, and that means we produce APIs, but we're also running the users' code themselves. So this means they have applications and we need to run those. So this introduces things like ABI compatibility issues. So this is application binary interface, or you can just think of this as the bytecode that gets generated when you compile your code. So for example, we have our existing project, our existing product. So we have quarter 4, we're kind of working on quarter 5 now. It's kind of stuck on Kotlin 1.2, which I don't even know how old that is anymore. It was kind of old when I joined maybe 4 years ago. So that kind of tells you how out of date it is. It's not a supported version anymore. It was not a supported version for a very, very long time. And so the reason why we kind of had to keep there is we couldn't keep our guarantee of not breaking existing compiled applications. If we've made these, because we've given this guarantee to our customers, we can't just kind of go back on that. And even if we really wanted to, it's not feasible. So moving forward, we've kind of got our new product, which is quarter 5. And kind of part of the reasons why we're kind of making this breaking change from 4 to 5 is for things like upgrading Kotlin, which we couldn't do while keeping this compatibility. But even when we did that, we still ran into some issues while kind of upgrading through versions, things that we rely on within our platform that are kind of breaking as we went through the new version changes. So for example, we kind of heavily rely on being able to serialize lambdas within our project. And some of these things kind of broke. They become unserializable by default in Kotlin 1.5. And that meant we had to kind of wait for the next version to come along so we can kind of keep our code working. So these are kind of just a couple of images of kind of some of the problems we ran into. Some of these tickets are raised by us, some of these tickets are raised by other people. The one at the top is obviously kind of our internal ticket that we made to look at it ourselves. These were all things that were kind of stopping us. Now, if you can actually see the image, it might be a bit small. Some of the descriptions on these bug tickets or stories, whatever you want to call them, they might look a bit daunting. They're probably not things you're kind of readily aware of. Synthetic methods, dollar annotations, it's not something you come across when you're just writing your normal code. These are very specific things that some libraries use, and unfortunately, you could say, in this scenario, our project is kind of making usage of. So this has kind of caused us issues in the past and kind of going forward. So this led us to the decision to rewrite our APIs in Java. With our users being primarily Java developers, Kotlin's benefits were kind of reduced. So that kind of eased the pain of making this decision, which, let's be frank, we didn't really want to make. We didn't want to write Java code. Even if it's not that much stuff we had to do, we still would have rather done it in Kotlin. But that's where we ended up with. And the main reason why we had to move, even with these factors that kind of mitigated the pain of doing so, is if we couldn't guarantee that future versions of Kotlin would be compatible with our applications which are compiled against the older ones, is a bit of a long thing to say. That kind of breaks our guarantees, as I keep saying, and it's just not feasible for us. There are also other reasons. They are quite complex, and I won't go into them because I don't fully understand them, so I didn't want to just be talking crap. That's what it is. But yeah, it's not perfect. Like, we don't want to be writing Java, really. I don't mind it that much. I actually quite like Java interfaces, but maybe I'm a bit weird with that. Yes, we are subjugating ourselves to more Java code in some places. Like if we've got some static methods which we're making public, there's a bit more code we have to write, so it's a bit more of a pain. But this is what we think will give us best long-term stability for our product. So I spent a lot of time kind of talking about really why we decided not to use Kotlin for APIs, rather than kind of talking about what is important. The talk is, should you be using Kotlin for APIs? So I'm going to spend the rest of the talk kind of going through that, and we'll see where we land. So I have split up kind of the different applications you can write into 4 areas. We have kind of internal code, which makes up half of it. So we have kind of internal monoliths and internal services. And then we have kind of more public things, which are libraries and platforms. So most code lives inside of these internal code bases. So if you have a monolith, just one single large code base, or a code base split up into many different services, as long as it's still internal and you don't have a public API that other people are using, there's not too much of a worry there. And that is primarily most of the code people will be writing. Most people are not normally writing code for other people to consume. The next up we have are libraries. So, I mean, we all kind of know what libraries are. We're all bringing dependencies into our code, and then we're interacting with these libraries through the APIs that they produce. We're not all writing libraries. Some very nice people are writing libraries for us to use, make them open source so we can kind of use those and simplify our code. So that's great. And then we have platforms, which is where Corda lives, which is where we have APIs that we provide for applications to code against, but we also provide a platform where we're running those applications once they've built them. So it's gone further past the library, which is just providing API. We're actually also running the code. And I would probably say these are the least common because I can't think of loads of scenarios where I've run into a platform myself, especially a platform where it's running code that has APIs. It's not just managing like a Docker container or an image for you. So yeah, as I kind of was saying earlier, the internal code bases, they don't really have codified APIs. They might have APIs between each other. So with the internal services, they might have endpoints, but these are normally not coded endpoints. You have kind of microservices, for example. You're not directly calling the API on another service. You're saying, I'm going to submit a request to an endpoint. I'm going to put something on a queue. Something is then on the other side picking it up and processing that work. So you're not directly interacting with a piece of code to trigger that API. Libraries, on the other hand, we are obviously interacting with these. And when we're talking about compatibility, and mainly because I'm talking about Kotlin APIs and Kotlin ABI stability, if you have a library and you upgrade your Kotlin version, say, and it's caused some issues, it's not the end of the world, because if your library wants to upgrade it, update the language it's built, the version it's built against, you can just say, this library supports this version. If you want to use this, you have to upgrade your language version as well. If you don't, you can use the older versions of the library, but you bring that in, you recompile after fixing any issues, and you move on. There's not really an issue there. That's something we all kind of expect, and we deal with. But again, platforms it's a bit harder than that. We still need to give these sort of guarantees. So we can't just say, just go and recompile your application. If we are saying these things still have to work, it is what it is. We have to keep them working. So this is kind of more of a visual version of what I was just saying, where we have internal code bases on the left-hand side, which they can upgrade their Kotlin version without really a care in the world, as long as the product is still working as intended. If users are still able to go to a web page, hit an endpoint, they see the right data, that's all they care about. They don't care what version of Kotlin is being used under the hood. They just care that the application is still working. So really, the Kotlin version upgrade doesn't really have an impact other than keeping things working. Libraries, on the other hand, if we're upgrading a language, that might then indirectly mean your own code needs to upgrade because a library is depending on something that's only released in a later version of that language. So there is going to be some impact. Who are the users in this case? You are the user. You as the developer is the user. So there is going to be some problems. You might have to fix up your code, but we can deal with that. It's not the end of the world. And then again, on the larger impact side of the scale, we have platforms where existing applications may break due to ABI changes. They might not always break, but they could. And if these breaks occur, then users must update their applications. But as I keep saying, if you're providing guarantee that they shouldn't have to do that. That might not be feasible. So I spent a while we're just going through the different types of applications there are. So once you've kind of figured out where you sit in those different choices and you've weighed up you've decided how much of an impact you're willing to push onto your users as you make upgrades, as you make changes to your libraries, your platforms, or your internal services, but that's not really an issue. So you need to also think about who you're providing these APIs for. It's not just a case of if it's a platform or a library, it's more what languages are they using? Are you just targeting users that are writing their code in Kotlin? Are you providing like a coroutine library? If you're providing a coroutine library, you don't need to care about Java compatibility. You are writing something specifically for Kotlin, so you have to use Kotlin. There's not really a decision there. Or are you writing something that's more of a general purpose library? Are you going to allow it to be used from Java, Scala, whatever else? There are now some more considerations that we've kind of went through in this talk that you have to make. You have to decide if that is something you're willing to do. And if it is going to be a general purpose one, are you willing to put in the work to make sure it's pleasant to use? You could decide that you are going to target other JVM languages, but you're just going to write basic Kotlin. You're not going to kind of make the extra steps. It will work. It's not everything becomes completely unusable. It's just not as nice. It becomes awkward in some places. Trying to match up examples you might have written in Kotlin. If you haven't taken these extra steps there, and if you have a Java user, they might be wondering, well, how do I do this? This thing doesn't exist in the same way it does in the example you gave me. So these are all things you have to consider when you're making your decisions in what language to write your APIs in. So I've kind of said earlier in the talk that there are some issues when we're upgrading Kotlin versions. These tickets are kind of proof that we've had problems in the past and kind of problems that we're still having going forward. But annoyingly for my own talk, and it's caused me a lot of stress over the last week, is it turns out Kotlin actually generally upgrades pretty smoothly. I tried to find some examples which I could just say, there you go, here's evidence that it breaks in some scenarios. I couldn't actually do that, which was kind of annoying. So you do actually have most changes are API compatible. You tend to actually end up in that, and again with these tickets with their kind of weird titles, they're kind of niche edge cases. Not all libraries are making use of these sort of things, which can break between versions. They're very, very specific. So the chances of you actually running into these problems, it's not super high, but they could happen depending on the libraries, the dependencies you're bringing into your code, or even what you are providing yourselves. So as an example, here's a change that was made many years ago in Kotlin 1.3, where I thought I had found an example where they broke API compatibility, and was kind of annoyed to find that it still actually worked, even when I changed the versions. So we have a renaming of a companion object. I didn't actually realize you could give a name to a companion object, so I learned that as well. But you can see it kind of at the bottom there, we've kind of made an extra object to allow applications written against the old version of this companion object to still work. So there would still exist something called random.companion, even though if you went to then write your application against Kotlin after this change was made, that thing doesn't exist. You would have to write random.default to directly access this companion object. You might not normally write that code. I know it's a companion object. You'd probably normally just write random dot whatever the static method is, but you can do it this way. But it actually turned out they didn't even need to make this change in the first place, which is not the worst thing to say, because it does mean the writers of Kotlin do care about API compatibility. So even though there are some edge case issues, generally they are making the right changes. So with this change, it turned out they didn't even have to make it API compatible, because the class, this random class, didn't even exist in the previous version of Kotlin. So it's wasted effort, but it's nice to show that they did actually make the effort, and they are considering doing this even though they didn't really have to. So in kind of summary, where do we end up? So should you be using Kotlin for your APIs when targeting JVM applications? In most cases, yes. You're not really going to run into that many issues. There's still things to think about, but generally it all works fine. But there are some cases where you might need to really think about it. You'll need to think about what your product is doing, and be aware if it's going to run into some of these edge cases. Are you using things that are specifically pointing at bytecode to look for very specific things? You need to be aware of it. Luckily, a lot of us are not using libraries like that, but some of us, we are, R3 are doing this. So that's why there are some cases where I could say I would advise against using Kotlin. Regardless of that, whether you decide to or you don't, you need to really choose a language that will most benefit your users. You don't want to be using Kotlin for your APIs just because you want to be writing Kotlin. I guess if you're doing something for yourself, or it's not meant to be a kind of really kind of large scale library that you're expecting millions of people to be using, you can just do whatever you want. You can be there to test things out. But if you are planning on writing something that you expect a lot of people to be using, you need to decide what is going to be best for them. If I am providing that library for any JVM language, what would they like it to be in? What would be most useful to them? Am I expecting to have a lot of Kotlin users? These are things we need to think about. And then once you've chosen a language, you still need to make sure that whatever you do, you need to write clean, friendly, and well thought out APIs for your users. It takes effort. We definitely know that in R3. We've been producing APIs for quite a while now, and the amount of iteration that goes through of, oh, we do this, oh no, that's not nice to use from that scenario, or doesn't work in this case. It's hard, but once you've got it right, your users are the ones who are going to benefit, which then directly leads to a benefit of yourself, especially if you're creating a product, because that is going to get it better used. People are going to think more nicely about that.